Welcome to this explainer. So today, we're going to break down all 10 brief answer questions from the TU 2077 statistics exam, and we're going to turn them into a dynamic, highly satisfying math sprint. If you've ever looked at a list of exam questions and just felt completely overwhelmed by the sheer variety of formulas you need to remember, well, you're absolutely in the right place. Let's deconstruct these problems step by step together. Okay, let's dive right into the actual paper. What you're looking at is the official Group A brief answer question section from the 2077 exam. And yeah, at first glance, it's just a giant wall of text and numbers. But you know what? By organizing these problems thematically, we can uncover exactly how logical and accessible these foundational statistics problems truly are. Instead of just running through a random numerical list, we've organized these 10 questions into our exam roadmap, broken down into 5 distinct sections of the statistician's toolkit. We'll hit time and trends, relationships and distributions, averages and consistency, grids and gambles, and then finally, the conceptual core. All right, section 1, time and trends, which covers questions 1 and 9. Let's see how this builds our understanding of measuring changes over time. For our very first problem, question 1, we're asked to forecast future sales using a provided straight-line trend equation. We are given the formula y equals 42 plus 3x, with our base origin year set at 2009. Our target here? Estimating the sales for the year 2016. What's actually really cool about this is how incredibly simple the math gets once you decode what x represents. X is literally just the difference in years from our origin. So we simply subtract 2009 from 2016, and that gives us an x value of 7. Then we just plug that 7 right back into our trend equation. So multiplying our slope of 3 by our 7 years gives us 21. Adding that to our base of 42 lands us squarely at an estimated 63. And since the problem notes that sales are in lakhs rupees, our final perfectly forecasted answer is 63 lakhs rupees in sales for 2016. Skipping down to question 9, just to stick with our theme of time, we recreate the exam's grid to compare prices of 6 different commodities across 2 years. We need to find the price index for the year 2066 using the simple aggregative method. To do this, we just sum up all the base year prices from 2065. Next, we sum up all the current prices from 2066. Then, you just divide the new total by the old total and multiply by 100 to get our index percentage. It's a really beautiful, elegant way to track inflation across a whole basket of goods all at once. Moving right along to section 2, relationships and distributions. This covers questions 2 and 3, where we look at the hidden architecture of our data. Question 2 hits us with a classic dense data dump. You know the type. We have our number of observations, our sums, our squares, and our cross products. And from all this raw material, we're asked to find the regression coefficient of x on y. The absolutely crucial point here is picking the right formula. Because it specifically asks for the regression coefficient of x on y, we have to use the formula that isolates y in the denominator. We take our n and sum totals, plug them into the numerator to find the covariance, and divide by the sum of y squared in the denominator. Letting the arithmetic do the heavy lifting here reveals the exact strength of that relationship. Now, for question 3, which is honestly a fantastic conceptual puzzle, we need to find the fourth moment about the mean. And the only piece of data we are actually given is that the standard deviation is 11. And this is literally statistical theory in action. Because it specifies a normal distribution, we know a secret rule. A perfectly normal curve always has a kurtosis of exactly 3. Since kurtosis is just the fourth moment divided by the standard deviation to the fourth power, we just set the equation to 3, isolate our missing variable, and multiply 3 by 11 raised to the power of 4. Okay, section 3, averages and consistency. This is questions 4, 5, and 6, where we unpack real-world applications like speed, salary equity, and data auditing. Question 4 is a famously deceptive trap. We have a cyclist traveling 3 consecutive 1-kilometer stretches at totally varying speeds, 10, 3, and 6 kilometers per hour. Now, if you just add those up and divide by 3, you'll get the wrong answer. Because the distances are equal, we have to use the harmonic mean, not a simple arithmetic average. So by putting our total distance, which is 3 kilometers, over the sum of our inverted speeds, we're essentially dividing total distance by total time. the fractions in the denominator smoothly resolve, giving our cyclist a true, mathematically sound average speed of exactly 5 kilometers per hour. Question 5 is a showdown between two companies. Company B pays a higher average monthly income of 2,750 rupees compared to Company A's 2,600. But wait, the question asks for consistency. To find that, we calculate the coefficient of variation for both by dividing the standard deviation by the mean. Whichever company yields the lower percentage has less variability, mathematically proving exactly which workers experience a more reliable, consistent paycheck. Question 6 puts us right in the auditor's chair. We've got 200 observations that average out to 50. But, oops, we discover that the numbers 45 and 54 were included by mistake. We need to find the new, corrected mean after dropping these two bad data points. First up, we just multiply our original 200 observations by the mean of 50 to find our total sum, which is 10,000. Next, we slice out the incorrect 45 and 54, leaving us with a new sum of 9,901. We then divide this new sum by our remaining 198 observations, landing us at a beautifully precise corrected mean of roughly 50.005. Up next, Section 4, Grids and Gambles, tackling questions 7 and 8. Let's test our structural logic and probability skills. Question 7 asks us to find the determinant of a 3x3 matrix. This is honestly such a satisfying, structured exercise. You take the top row numbers, 3, 4, and 5, and systematically multiply them by the cross products of the remaining 2x2 grids beneath them, carefully alternating your addition and subtraction. It perfectly turns a rigid grid of numbers into a single, scalable value. For question 8, we're hitting the craps table. What is the probability of rolling a sum of 7 or 11 in a single throw of 2 dice? Notice how visually mapping out the dice combinations proves exactly why the math works here. There are 6 ways to roll a 7 and 2 ways to roll an 11. That gives us 8 winning combinations out of the 36 total possible outcomes, which simplifies down to a really neat 2 in 9 chance. And finally, Section 5, the conceptual core. Here we step away from the heavy calculations with question 10 to bring our math sprint to a calm landing. Question 10 steps back and just asks for the basic concept of classification of data in statistics. Notice how it's defined as the process of arranging raw, messy information into homogeneous, structured groups based on common characteristics. Honestly, that's exactly what we've done in this explainer today, right? We took a random exam paper and sorted it into digestible, thematic lessons. So as we wrap up this TU 2077 exam breakdown, it really leaves us with one provocative thought to ponder. If statistics is ultimately just the logical classification of the universe's chaos into manageable patterns, what messy, real-world problem will you conquer next using this exact toolkit? Keep learning, keep structuring your data, and I will see you in the next explainer.